The universe is a true mystery, even with all the advancements we've made. How is it possible that there are still so many unanswered questions? How was it created? Why? And for what purpose? These are questions that haunt us and can even leave us perplexed. What we can say for sure is that science continues to search for clues to these answers. And this is where today's protagonist comes in, the James Webb Telescope. It has challenged everything we thought we knew about the formation of planets, stars, and galaxies. In this video, we will talk about some discoveries that simply shouldn't exist, at least according to what current science believes. Welcome to the Enigma Vault channel. If you enjoy exploring the mysteries of the universe and the most surprising scientific discoveries, don't forget to like, subscribe to the channel, and share this video. Your support is essential for us to keep bringing fascinating content like this. Are you ready for a journey that might change the way you see the cosmos? Then stay until the end and together we'll dive into the deepest secrets of the universe. Now that you have an idea of what we're going to explore, it's time to dive deep into the discoveries made by the James Webb Telescope. Get ready, because each of these discoveries challenges what we know and opens doors to even more intriguing questions. Science is showing us that the universe is far more complex and fascinating than we ever imagined. Let's begin our journey with the exoplanet K2-18b, located about 124 light-years from Earth in the constellation Leo. What makes this planet one of the most studied targets by astronomers is the fact that it lies in the habitable zone of its star, a region where conditions may allow for liquid water to exist on its surface. In 2019, scientists made an impressive discovery. Water vapor was detected in this planet's atmosphere. This was the first time water vapor was found on an exoplanet located in the habitable zone, which immediately raised the possibility of it harboring life. However, the most incredible part comes now. With the James Webb Telescope, new observations revealed the presence of molecules such as methane, carbon dioxide, and dimethyl sulfide. The latter, on Earth, is mainly produced by living organisms like phytoplankton. This scenario raises the big question: could there be life on K2-18b? We cannot say for sure yet, but the combination of these gases may suggest that something is happening there beyond purely geological processes. What makes this even more intriguing is the hydrogen-rich atmosphere, which suggests the existence of a deep ocean covered by a dense atmosphere. On the other hand, there are significant challenges to the idea of habitability on this planet. It is considerably larger than Earth, and scientists believe it may have a thick ice mantle under extremely high pressure, similar to what we see on Neptune. If the ocean is too hot or difficult to access, the chances of life as we know it diminish. However, these discoveries challenge our imagination about how and where life might exist. Now let's journey to the Serpens constellation, a region full of mysteries where stars are constantly forming in a fascinating environment. The James Webb Telescope has revealed stunning details of a nebula located there, a giant cloud of gas and cosmic dust that serves as a stellar nursery, where new stars are born from the collapse of gases. One of the most intriguing regions in this constellation is the Serpens South Nebula, an area rich in gas filaments where newly formed stars emit high-speed gas jets called outflows. These plumes of gas collide with the surrounding material, creating shocks that are visible in vibrant colors in the infrared images captured. The rare and unusual alignment of these outflows has fascinated astronomers, leading them to compare these phenomena to God's fingerprints, suggesting a majestic work of cosmic creation. What makes this place even more special are the conditions that foster the formation of stars of various masses, from small ones like the Sun to supermassive stars. The W40 Nebula, for example, is one of the closest star-forming regions to Earth, and studying these environments can help us better understand how our own solar system formed billions of years ago. Stars, planets, and planetary systems are born from these dense clouds of dust and gas. What we observe in the Serpens constellation are the early stages of a star's life, from the collapse of gas to the formation of protoplanetary disks, which will eventually give rise to new worlds. It's almost like watching the birth of a solar system in real time. Our next stop takes us to one of the most astonishing discoveries ever made, a structure of 10 galaxies arranged in a thin, long line, forming a filament about 3 million light-years long. This discovery, made by the James Webb Telescope, was observed just 830 million years after the Big Bang, making it one of the oldest and most complex structures in the known universe. This cosmic web challenges what we understand about how galaxies form. For a long time, we believed that galaxies were more isolated in the early universe and only later formed large structures. However, what the James Webb revealed is that, even in the first billion years of the cosmos, galaxies were already organized into filaments, interconnected by dark matter, as if they were invisible threads permeating the entire universe. These galactic filaments are not only formed by galaxies, but are also fed by dark matter and gas flowing along their structures, nourishing the formation of stars. And there's more. This web is anchored by a quasar, a galaxy with a supermassive black hole at its core that emits colossal amounts of energy. This suggests that black holes play a key role in forming these structures in the early universe. Lastly, let's talk about a discovery that may be considered one of the most enigmatic so far, the so-called floating binary Jupiters. What are these objects? They are pairs of giant gas planets orbiting each other, but they are not gravitationally bound to a star. In other words, they are planets wandering through space, challenging traditional notions of planetary formation. These planets were detected in the Orion Nebula, one of the most active star-forming regions near Earth. They are similar in size to Jupiter, but what's most astonishing is the fact that they are orbiting one another without a central star. How is this possible? The most accepted theory suggests that these planets may have formed around a star and were ejected at some point due to intense gravitational interactions. But the fact that two such massive planets were expelled together and remained bound to each other is extremely rare. Another hypothesis is that these planets formed directly from the collapse of gas and dust clouds, never having orbited a star. What's most fascinating is to consider the implications of this. If planets can form and exist without the gravity of a star, what other possibilities does the universe hold for us? Could there be more floating planets out there, invisible to us until now? And even more intriguingly, could these worlds harbor forms of life under completely different conditions from those we know? If you thought the floating planets were the pinnacle of discoveries, wait until you hear what the James Webb Telescope has revealed about supermassive black holes. These cosmic giants, with masses billions of times greater than our Sun, defy our current understanding of star formation. Even more astonishing is that many of these black holes were detected in galaxies formed only about 800 million years after the Big Bang. How could these massive objects have grown so quickly in such an early stage of the universe? Supermassive black holes observed in the early cosmos present a paradox. Their growth rate is shockingly fast. To reach such enormous sizes so quickly, they must have either formed from incredibly large initial seeds or accumulated matter at an extraordinarily rapid pace. This contradicts conventional theories, which suggest that black holes should grow slowly by absorbing gas, stars, and even other black holes over time. The James Webb Telescope has captured detailed images of quasars' extremely bright galaxies with supermassive black holes at their centers. These quasars shine brighter than all the stars in their galaxy combined, allowing astronomers to study distant black holes and the first galaxies ever formed. But the big question remains: how did these black holes grow so large, so fast? And what can they teach us about the formation of galaxies and the evolution of the cosmos? This is one of the greatest mysteries in modern cosmology, challenging everything we know about physics. Could we be on the verge of a new scientific revolution? The James Webb Telescope is rewriting what we know about the universe, revealing mysteries that challenge our understanding and pushing the boundaries of science. From planets that may harbor life to the formation of stars and galaxies that defy our theories, each discovery brings us closer to uncovering the secrets of the cosmos. If you enjoyed this video, don't forget to subscribe to the Enigma Vault channel, like, and share it with your friends. And if you want to continue this journey of discovery, check out our other videos where we explore mysteries ranging from theories about us being aliens to unexplained disappearances.